Good morning, viewers. In this class, we discuss about the definition of longitudinal waves and the transverse waves. So now, definition of longitudinal waves. Definition of longitudinal waves. So here, whenever the wave is traveling, is propagating, or in case of wave motion, what is happening? The particles of the medium vibrate. So, if the particles of the medium vibrate along the direction of the wave propagation, then those type of waves are called longitudinal waves. That means suppose a wave particle, suppose this is first particle of wave, second particle of wave, third particle of wave, fourth particle of wave, fifth particle of wave, like this. These are the particles of waves. So what is happening here? These particles are vibrating. So what happens here? In case of vibration of the particles, so this is the vibration. Suppose the wave direction, this is the propagation of the wave propagation. This is the direction of wave propagation. This is the direction of wave propagation. What about this? Suppose this is first particle, this is second particle, third particle, fourth, fifth, sixth, seventh, like this. So these particles are vibrating. Vibrate means this first portion it vibrates towards left side and right. So left extreme point this is left extreme point. This is right extreme point. Right extreme position. Right extreme. So left extreme or right extreme. In the same way, second particle also comes to left and right. Third particle also comes to left and right. So what is this position is called mean position. This is a mean position. Okay. Now this first particle is vibrating about its mean position. Means towards it is coming towards left side and going towards right side about their mean position. This position is called extreme position. So what is this one? Extreme position. And this is also called extreme position. Extreme position. See what is happening here? So first particle is vibrating about its main position. This is the blue line is there. That is first particle. That is called mean position. If it while it is vibrating, it comes to extreme, left extreme. Again it comes to mean position. Again it goes to right extreme. Again it comes to mean position. It comes to left extreme position. Again like that. It is vibrating. So vibration means it is left. It coincides. It reaches to left extreme, right extreme. About this, to and fro motion. To and fro motion is called vibration. To and fro motion is called vibration. One to and one fro motion is called one vibration. So here, okay. Now, so how this particle is vibrating? It is vibrating along horizontal direction. In the same way, for second particle also reaches to its left extreme and it comes back to mean position and again reaches to right extreme position. Okay, so left extreme, right extreme. So like this, the first particle vibrating, second particle vibrating, third particle vibrating along horizontal direction means in the direction of the wave propagation. That means if the direction of the vibration of the particles of the medium are parallel to the direction of wave propagation, then that wave is called longitudinal wave. So I am writing the definition. If the direction of the wave propagation, if the direction of the vibration of the particles of the medium, if the direction of the vibrations of the particles are the direction of the vibration of the particle, of the medium is parallel to the direction of wave propagation. Direction of wave propagation. Wave propagation. Then those waves are called longitudinal waves. Those waves are called. Then those waves are called longitudinal waves. I think you understand. See, if the direction of the vibration, so how the particles of the medium are vibrating along horizontal direction in the direction of propagation, in the direction of the wave propagation. Wave direction this is. I am showing this direction. This is the direction of the wave. Means from left to right the waves are forming. Waves are moving. So how the vibration of the particles? So the vibration of the particles are also along the horizontal direction only. So if the direction of the this you can write as a vibration is parallel to wave direction. Vibration of the particles parallel to wave propagation. Then those waves are called longitudinal waves. So this is the definition of longitudinal wave. In longitudinal waves, compressions and reflections are formed. Already about longitudinal waves, I explained in the previous session. So this is the definition of longitudinal waves. If the direction of the vibration of the particles of the medium are parallel to the direction of, if the direction of the vibration of the particles are parallel to the propagation of the wave propagation, then those waves are called longitudinal waves. Copy this. Next one. Yes, next one. Next one, definition of transverse waves. Definition of transverse waves. Definition of transverse waves. Transverse wave. See here. So suppose how the transverse waves formed. See, this is the direction of the transverse. This is the direction. This is the representation of the transverse wave. See here, in this what will be formed? Crest trough. So here, what is the wave direction? Wave direction is horizontal. But how the particles are vibrating? So first particle is perpendicular. It is vibrating. Second part, see, perpendicular direction there. So what is the direction? This is perpendicular to the direction of the wave. So this is the perpendicular. So here what is happening? All the particles are vibrating, but how they are vibrating? They are perpendicular to the direction of the wave propagation. The same way come to the trough. How these particles are moving? This particle is moving downwards, perpendicularly. So upwards or downwards. See, if the particles of the medium, what is the definition of transverse waves? If the particles of the medium, if the vibration of the particles of the medium, if the vibration of the particles of the medium are perpendicular to the Direction of wave propagation. Direction of wave propagation. Wave propagation. Then those waves are called transverse waves. So in transverse waves, what will be formed? Crests and troughs. So this is about definition of transverse waves. Already in the previous session, I explained about transverse waves by how we can what is the structure of transverse waves, like that. So this is about the definition of transverse wave. Copy this one. Like the video, share the video, and subscribe our channel, IBJ channel.